Okay, guys, this is a video to help you get started on Intro to Scatter Plots Day 2. Okay, it's just kind of an introduction to the newer stuff. Okay, so I'm going to look over slides 3 and 4. Okay. We already talked about association, like positive, negative, linear, nonlinear. We looked at some vocabulary, like outliers. Okay, so for the 3 main problems, I'm going to have like one slide asking you questions about the relationships. And then the second slide for each problem is working with a line of best fit. Okay, so let's do slides 3 and 4. I think that'll help get you started on the rest of them. Okay, let's look at slide 3. We're looking at time studying for a test versus test scores. Okay, so maybe we asked a bunch of kids in the class how many hours they studied, and then we figured out what their test score was, and we put a point to represent that situation. Okay, so here's a bunch of points showing that. Okay, so let's think about these questions before we start doing the line of best fit. As the hours increase, the test scores increase or decrease? Okay, as the hours go from left to right, think left to right, because that's what you do when you read anyway, is you go from left to right on the x-axis. Okay, as the hours studied increase, okay, what happens to the test scores? You can just kind of look at the heights. Okay, they increase. Okay, what kind of association? Is it linear, nonlinear, or none? Okay, well, linear means that the points kind of hover around a line, and they do. Okay, so it is a linear association. Is it a positive or negative association? Okay, well, if the points are going up from left to right, it is positive. If the points were going down from left to right, it would have been negative. So you can just use those to highlight the correct answer. Is there an outlier? I'm going to say this is a outlier right here. And it looks like it's about what, 80, 90, about 95. This point is far away from the others. Okay, I'm going to call it point 0.095. And think about what's going on with that point. Okay, the 0.95. Okay, it looks like someone got a 95 test score with studying. Okay, this is the hours studied on the x-axis for 0 hours. Okay, so lucky kid. Okay, the student studied 0. You know what? I'm just going to put didn't study at all. Because if he studied 0 hours or she studied 0 hours, that means they didn't study at all. So the student didn't study at all and earned a grade of 95. Okay, and you know you're going to word things differently, I'm sure. Okay, now let's do a line of best fit. Well, they give you the line of best fit. They give you a line that goes through the middle of the data, and you practiced that the other day. But what I want to do is find the equation of that line of best fit, and then use that equation to make a prediction. Okay, so breathe in. Okay, take your time with this. Okay, first thing you want to do is to find 2 points on the line so you can find the slope. And this confuses people. Don't find 2 red points. We don't even care about the original red points anymore. I'm just looking at the line now, okay? I'm just looking at this line. I want to find 2 corner points that are on this line. And I gave you these arrows. I don't know if it will help, but it kind of helps me. I think that point right there is kind of a good corner point. And that point right there is pretty good on a corner point. Pretty good point on the line that's on a corner. So you can tell there. Okay, so we're going to use those 2 points on the line, first of all, to find the slope, because we need to find the slope. We need to find the y-intercept so that we can find the equation. Okay, now breathe in, guys. This is the tricky part that makes these a little, harder than what we are used to. The y-axis and the x-axis are not counting by ones. And they're going to be counting by different things on these scatter plots. So take a look at this y-axis. Just take a look at maybe between 60 and 80. Okay, there's 4 spaces between 60 and 80. That means halfway between would be 70. Okay, so here's 70. Well, if there's 2 spaces between 60 and 70, that means we're counting by 5s on the y-axis. We're counting by 5s. Let's see. If this is 60, this would be 65, 70, 75. There's my 80. Okay, you got to know that. You got to know you're counting by 5s on the y-axis. And on the x-axis, let's see, here's 1 hour, here's 2 hours. Halfway between would be 1.5 hours. Okay, so I'm going to think of that as 30 minutes. Say 1 to 2. Okay, half of an hour. I'm just going to think of 2 spaces is equal to, I'm going to change my mind on what I just said. I'm going to think of that as a half hour. So 2 spaces is a half hour. You could say 1 space is a quarter hour, but I'm not going to need that. Every 2 spaces on the x-axis is a half hour. So what I'm doing, when I go from this point to this point, I'm going up 1 space, okay, but 1 space is 5. So I'm going up 5, and then I'm going over 2 spaces, okay, but 2 spaces on my x-axis is really half of an hour. Okay, so I'm going to go up 5 over a half. Guys, that's the hardest part of this, is just really thinking about how much the spaces are worth. So my slope, rise over run, I'm going up 5 over a half. 5 there. Okay, so I need to divide 5 by a half. Okay, if I take 5 divided by half, I don't care if you use a calculator, 5 divided by half is like 5 times 2 over 1. Copy, change, flip. Okay, you get 10. Okay, the slope's 10. The slope is 10. Even though it doesn't look like it, it's because the numbering's different. The slope's 10. The y-intercept is where it crosses the y-axis. There's the y-axis. Maybe 61. I'm going to put 61. Guys, these are approximations. You're not going to always agree with another person when you do this. 61. So if I know my slope is 10, I know my y-intercept is 61. My equation is y equals 10x, put the slope in front of the x, put the 61 at the end, the y-intercept at the end. So we get y equals 10x plus 61. Okay, that's the hardest part, especially the figuring out the slope. So take your time with these. Okay, make a prediction from your equation, the test score for studying 2.5 hours. Okay, so they're giving us 2.5 hours. They want us to predict the test score. Of course, you could look at the graph. You could find 2.5 hours, kind of go up here, straight up, straight over. Looks like about 90. Okay, you could actually use the graph, but they want you to use the equation. Okay, so to use the equation, we're going to take this equation. We're going to replace x with the 10. Okay, the x values in our equation, x stands for hours. So we're going to replace x with 2.5. So they're giving us 2.5 is x. 2.5 is the hours. We're going to replace this x with 2.5. I don't know why I said 10. So we're going to take 10 times 2.5 plus 61. So I'm just going to take 10 times 2.5 first. Okay, multiply before you add 25. Add 61. And if you take 25 plus 61, okay, let's see, you get 76. So predicting from the equation for studying 2.5 hours, you would get a test score of 76. Okay, guys, take your time with this. Okay, the Khan Academy lesson is just like this. The trickiest part is when you find your corner points, think about what the spaces really are in terms of how much they're worth when you rise and you run. I think if you get that, I think you'll be fine. Okay, find your slope, find your y-intercept, form the equation from those two, and then put the value that they give you in for x to make your prediction. Okay, let me know if you have any questions.